Hi everybody. Welcome to section 10.5a, Pythagorean Theorem. This is a really nice way to end the year because it's got some good math in it, good algebra, which I know all of you love. It has to do with squaring and square rooting things, which is what we're working on in chapter 10. And it also is a good head start into geometry. This is one of the first things that you'll do in geometry next year, and I know everybody's excited for geometry. So hopefully you've heard of the Pythagorean theorem. We're going to solve problems, we're going to find missing sides, and we're going to decide whether, if I give you a triangle with sides, is it a right triangle? So first of all, we need to make sure we know what a right triangle is. A right triangle is any triangle that has a right angle. So a right triangle, I'm going to use the triangle symbol. Any triangle with one right angle. And you know what a right angle is, right? 90 degrees. And we signify it with a little square in one of the corners. Whatever corner has a right 90-degree angle. So Pythagorean theorem says in words, I didn't want you to write this out, in a right triangle, only a right triangle, the sum of the measures of the legs equals the square of the measure of the hypotenuse. Or, in easier terms, a squared plus b squared equals c squared. The c squared is always the hypotenuse, the longest side, opposite the right angle. So if you look at the diagram over on the right-hand side, you'll see how it's labeled with small a, small b, and small c. This small c is the hypotenuse. And these two guys, a and b, are legs. The legs make up the right angle. So hopefully you know all this stuff and have seen it before. If not, we're going to make sure that you've got this. So I got a couple practice problems to start just using the Pythagorean theorem. Find the length of the missing side. So if we do problem number 1, notice I've got a 3, a 6, and a D on my missing sides of triangle PQR. Which one of those three lengths, 3, 6, or D, is the hypotenuse of this triangle? So here's the right angle. I always think of it as the right angle's pointing at the hypotenuse. So we know that the hypotenuse in a squared plus b squared equals c squared. The hypotenuse is always the one that's by itself. So we know it's going to be equal to 6 squared. As far as the legs go, it doesn't matter which order you put them in, as long as you have those two being squared and added. So 3 squared plus d squared equals 6 squared. So now let's do a little bit of squaring and then solve an equation. So 3 squared is 9. 6 squared is 36. Solve this the old-fashioned way. Let's start by getting rid of that 9. So d squared equals 27. And now I know that you know what to do, right? Because if I've got a d squared, I don't care what d squared equals. I want to know what a plain old d is equal to. So that means I'm going to have to square root both sides. Square rooting and squaring cancel each other out. Square root of 27, we could break that down, right? 27 isn't a perfect square, but it's the same as 9 times 3. We know that 9 is a perfect square. So 3 square roots of 3. If I asked you to round it, this would be an exact answer. If I asked you to give me a rounded answer, you would actually type into your calculator the square root of 27, and you would tell me that d is approximately 5.2 centimeters. So I'll try to be specific, or ask me, do you want an exact answer or a rounded answer? So let's do number 2. We'll skip number 3. Number 2, I've got an x, a 20, and a 37.5. Which one of those three values is the hypotenuse? that x is, right? So that means that the x squared has to be by itself. So I've got either leg in either order, 20 squared plus 37.5 squared. If you ever start with a decimal in the problem, just go to a decimal or a rounded answer, because that's crazy trying to square root and break down decimals. So when I go to my calculator, I'm just going to type this straight across. I'm just going to do 20 squared plus 37.5 squared because it's not really an equation to solve. When I did that, I got 1,806.25. It's still equal to x squared. Don't forget that your last step is going to have to be to square root that. And believe it or not, even though we got a crazy decimal answer, when we square root it, we actually get a nice, neat answer. It's not even rounded. I'm going to use straight equal signs, 42.5. So that missing hypotenuse on that triangle must be 42.5 units, whatever that is, inches, centimeters, feet, miles, whatever. All right. So let's talk about the converse of the Pythagorean theorem. Converse means we switch it. So in other words, if a squared plus b squared equals c squared, then the triangle has a right angle. Whoops, right angle. So this is where we're going to test a triangle. I'm going to give you the three sides. We're going to test to see if it is right. So we're going to see, does Pythag work? If the Pythagorean theorem works, then we know we've got ourselves a right angle. And a Pythagorean triple, oh, I've already got it there. If you've got three whole numbers that satisfy Pythag, then it's a Pythagorean theorem, or Pythagorean triple. It's got to be whole numbers, though. None of this decimal fraction radicals, anything like that. It's got to be nice, neat, whole numbers. And of course, they'll always be positive because you can't have negative side lengths. So let's decide if we've got ourselves a Pythagorean triple. Let's do 1 and 3. Let's skip 2. So number 1, notice how I gave you 3 side lengths. The hypotenuse is always the longest side. It's just the rule. So if I switched up the orders on these, you know that the longest one has to be the hypotenuse. So I know the 15 has to be squared by itself. The other 2 legs squared. And again, this is a check step. We're checking to see if that works. So it's a question mark. Is 9 squared plus 12 squared equal to 15 squared? So do the math. 9 squared is 81, plus 12 squared is 144. Does that equal 15 squared, which is 225? I think it's going to work, right? 225 equals 225. Whoops. I'm pretty sure we've got ourselves a right triangle. So I'm going to put down here, right triangle. The directions are also ask us, state whether they form a Pythagorean triple. So to be a Pythagorean triple, they have to be whole numbers that Pythag works. So are they whole numbers? 9, 12, and 15. Does Pythag work? So this is a Pythagorean triple. Easy, right? Just do the test and then look to see if they're whole numbers. So number 3, let's check this one. So we're going to do the same thing. We're going to check Pythag. I believe if I type 4 square roots of 3 into my calculator, it's 6 point something or something like that. So I'm pretty sure 8 is the longest side, so it's got to be the hypotenuse. So I know it's going to be 8 squared all by itself. And I know that everybody knows what to do with a 4 square roots of 3 squared. Right? We write that out 2 times, multiply our whole numbers, multiply our radicands. So I get 16 square roots of 9. So I'm going to multiply that 3 I just got and the 16 I already had, so that should be 48. Plus, I forgot to put my question mark, 4 squared is 16, Agree or disagree? 48 plus 16 equals 64. I think that works, right? So this is a right triangle. If we got like 64 equals 63, we know it's not a right triangle. So then, state whether they form a Pythagorean triple. To be a Pythagorean triple, they have to be whole numbers and Pythag has to work. When you look back at your original, are they all whole numbers? That 4 square roots of 3 really screws things up, right? If you type it into your calculator, do you get a whole number? Even though when we squared it, we look at the originals, not a Pythagorean triple. And I'm going to put in parentheses, because of that 4 square roots of 3 is not a whole number. I could see on a quiz where I would say, on answer line I put right triangle, yes or no, Pythagorean triple, yes or no. It's just a yes or no question. So number 3 is a right triangle, but not a Pythagorean triple. Number 1 is. If you tested out number 2 and did the math, I'd be willing to bet that that is not a right triangle, so it can't be a Pythagorean triple because it doesn't work. Pythag doesn't work. So here's what I would like to know. How do you tell the difference between a hypotenuse and a leg in a right triangle? And please do Pythag to find the length of that missing side. The first thing you have to decide is, are you looking for a leg or a hypotenuse? That is it. We'll see you guys next time.